So in this particular lecture we are going to talk about Rolle'S theorem. Let me write it in black. So we're going to talk about Rolle'S theorem and Lagrange's theorem. First let us start with Rolle'S theorem. So what does Rolle'S theorem say? So for some real function f, if point 1 f is continuous in the closed interval ab, okay, f dash exists on the open interval ab, if a is equals to fb. Clear? Okay, so if these three conditions are true, is f is continuous in ab, f dash exists in ab, and if a equals to fb, then there exists some c belonging to the interval ab such that f dash c is equals to 0. Clear? So basically these are the three conditions required. That is, for some real function f is continuous in ab, f dash exists in the interval in the open interval ab, and f equals to fb, then there exists some c belonging to the ab such that f dash c is equals to 0. Clear? So this is what Rolle's theorem says. So the graphical description can be something like this. Okay, so this is, say, x equals to a, this is x equals to b, and this is your fa equals to fb. So this is one c, suppose this is c1, this is c2, this is c3. See, at each of these x coordinates c1, c2 and c3, the first derivative is 0 because the tangent at those points are parallel to the x-axis. Getting my point? So this is what Rolle's theorem says. Now how can we prove Rolle's theorem? So proving Rolle's theorem is quite easy. So see, first we are assuming that all the conditions are actually valid. That is, f is continuous in ab, if its first derivative exists in ab, over interval ab, and that f equals to fb. Okay, these three things we are assuming to be true. So now we are doing is that m and this are the max and min values of f in ab. Clear? Not closed interval ab but open interval ab. Okay, m and m are the max and the min values of f in the open interval ab. Clear? Now if m and m do not exist, what does this mean? So this means that the there is no maximum and no minimum value to the function f. So that basically means that the function is constant. So the function is basically a constant. Clear? Which actually depicts that the maximum value is equals to the minimum value, or the function is a constant. If the function is a constant, then its first derivative will be 0 for all x belonging to the interval ab, and thus Rolle's theorem is 100% satisfied, because there is nowhere told that there must be only one value of c. There can be more than one values of c itself. Clear? But if the function is not constant, that is the maximum value and the minimum values are different, then what can we do? Actually, let's see. So I'm rubbing this portion here. Okay, so basically so since it is an open interval, so since it is an open interval, so basically m or m are not equals to fa, and similarly not equals to fp. So m and m lie between fa and fb. Now since m and capital M and small m are maximum and minimum values, so f dash x must be equals to 0 at m and m. Clear? At the maximum value or the minimum value, the first derivative must always be equals to 0. We already know this from the concept of maxima and minima. So therefore there is surely existing a value of x for which the first derivative will equal 0. It does not matter whether the function is constant or not constant. However, I mean, whichever be this, whatever be the situation, the Rolle'S theorem is always satisfied, given that the function is continuous in closed interval ab, its first derivative exists in open interval ab, and f equals to fp. Clear? So next we have something called the Lagrange's theorem. Let me write that too. So one second guys. So Lagrange's theorem. So Lagrange's theorem basically says that if f is continuous in closed interval ab, if f is f dash exists in open interval ab, then there exists some c belonging to ab such that f dash c is equals to fp minus fa over b minus a. Clear? Clear? Acha, carefully notice what this is actually is. See, suppose we have a curve like this. This is x equals to a. So basically we can write the coordinate as like this. Let's say we are writing it like this, that is x is equals to a and y is its corresponding y coordinate. This is xb and yb, that is x is equals to b and y is its corresponding y coordinate. Basically when x equals to a, y must be equals to fa, and when x equals to b, y is equals to fb. So if we join a line like this and we try to find the slope in between these two coordinates, then we can write it like this, yb minus ya over xb minus xk, which can be written like this, right? So fb minus fa over b minus a. Clear? So basically this thing is actually giving you the significance of derivative, that is there exists some point c such that f dash c gives you the slope. This is actually the slope of the basically slope of the tangent. Okay, see, if this point is say c1, this point is say c2, this point is say c3. So basically whatever will be the slope of this particular line, it joins the extremity or not extremities, the ending points, the start and the initial and the final point of the curve. At these points the tangents will have the same slope. Clear? Got it? Okay, let us understand the proof of this particular theorem. So this can be proved like this. Let phi x is equals to fx minus fb minus fa over b minus a times x. Clear? Now phi x will be continuous in the closed interval ab, and phi dash x exists in open interval ab. You can check it on your own if you know how to check the existence of derivative in an open interval. Clear? Clear? This will always be true for a function for this particular function. Further we have c phi of a is equals to fa minus afb minus a minus AFA over B minus A, which will actually be BFA. Clear? So this will be BFA minus AFA minus AFB plus AFA over B minus A. So these two will get cancelled. Similarly, your phi B will also be coming out to be BFA minus AFB over B minus A. So your phi A will actually be equals to phi B. Clear? So from here you will actually be getting that by Rolle'S theorem. By Rolle'S theorem, there exists some C which belongs to the interval AB such that phi dash C is equals to 0. That implies that f dash C minus fb minus fa over b minus a equals to 0. That implies f dash C is equals to fb minus fa over b minus a. And this is your Lagrange's mean value theorem. This is called Lagrange's mean value theorem. Okay, LMT or Lmvt, whatever you can call it. So this is its proof using Rolle'S theorem. Clear? Got it? So this was all about Rolle'S theorem and Lagrange's theorem, guys. In the next lecture I will try to bring a lecture on Cauchy's mean value theorem, which is also called CMVT. So we will be meeting in the next lecture.